Okay, we're going to look at section 8.2, which is really, in all honesty, the exact same concept that we were dealing with for 8.1. It's just that the shape of our curve is going to look a little different. Let's take a look, maybe just jumping into example 2. Very quickly, I just want to still make this comment that we, of course, could go back to making a table even by hand. That's always going to be an option. Nonetheless, we could jump in and use a graphing calculator. This will be 2 times parentheses. Remember, fractions are just entered as putting in a division symbol. 1 divided by 5. We'll raise that up to the x power. And very quickly, we could now see a table. Second table, we've already set up our table to actually have a beginning, perhaps at a set location. This is leaving off where I had done 8.1 problems. Negative 10, in the past, negative 10 would almost always yield very small numbers, but not this time. We're seeing we're getting some very large numbers. You can see even with x equaling negative 4, we'd be at 1,250. At negative 2, we're at 50. At negative 1, we're at 10, and so forth. So my goodness, we are seeing more or less a decline in our y values. Our y values are getting smaller and smaller. At negative 2, it looks like we're at 50. And then we're going to be at 10. Then we were at 2. Then it was 0.4. Then I believe this was 0.08. We can bring the calculator back to see that. Notice what happens as we continue to scroll down. Our y values are getting smaller and smaller. Now, what we could do at this point is very quickly realize that our scale does not have to go between negative 10 and 10 for our y's. Of course, we could still make that so. We could ignore the negative 250, 50, and just say negative 1, 10. That would be 1 to the left, up 10. 0, 2, we'll just go up 2 steps. 1, 0.4, that's roughly about right here. 2, 0.08, well, that's very, very low. You could not only get a table, but by pressing graph, you could see a very quick sketch on a negative 10 by 10 window. This curve should look somewhat familiar to what we were doing in the previous section, but of course it is different. What you're seeing is this. Your curve is going to be in decline. It's getting smaller and smaller over time. Our horizontal asymptote is going to be, you will notice that your y values got smaller and smaller. It's the x-axis, y equals 0. Your domain, once again, all reals. Very quickly, what about your range? Well, again, tied to this number for our horizontal asymptote, y is greater than 0. And this general shape that I just made up above on the graph and what I'm sketching right here is what we see for exponential decay. We're going to talk more about that in a moment, but great similarities to what we were doing on section 8.1. We can make a table either by hand with a scientific calculator or a graphing calculator, quickly make a graph. There will be a flattening out for the curve, just like we saw in section 8.1. We will see the same thing for 8.2. Tell you what, for example 3, we're not going to do that for the sake of time, but this right here was x files. If we saw the x minus 2, this is going to be shifting the graph y equals 1/3 to the x. 2 steps. Remember, x files is weird. It's not going to move 2 steps left. You see a -2, you think you're going 2 steps left. You're really going to move 2 steps to the right. The bottom line, though, is that your horizontal asymptote, the flattening out, is not going to be any different for this curve. By way of comparison, however, if we took a look at example 4, we do see a +2, an addition of 2. It's not right next to the x. This is not x files. This is not a movement in the x direction, left or right. Rather, we're going to see a vertical shift. And very quickly, with a calculator, we can get some assistance. Again, the calculator can be such a great help. Let me just clear this out. We'll type in 1/3. We'll hit caret x, and then say +2. Now again, if you were using an older version of the calculator, most of you are, what you would see is y1 would be 1/3. You would see the caret symbol on your calculator screen. This right here is what it would look like. Well, all the same, we could go to second table, and very quickly you can see it. -2 evidently would be at 11, and then at -1 we'd be at a 5. At 0 evidently we'd be at a 3. At a 1 we'd be at 2.3 repeating. And if we plugged in a 2, evidently we'd be at 2.1 repeating, just to see what's happening. You can see if we scrolled upwards, our y values are getting larger. If we were, say, to move down some more, our y values are getting smaller, but what are they getting closer to? Take a look at these numbers. They're all having a 2 in there, like a 2.1. Sometimes kids will say, oh look, when x equals 10, your y value actually equals 2. Not really. If you put your cursor over it, you'd see that it's 2.00001, and so forth. So, in any event, let's see if we could quickly plot this out. 2 steps to the left and then up 11. Well, we'd go even 1 step above. It would be something like that. -1, 5, 1 to the left, and then 1, 2, 3, 4, 5 steps up. 0, 3, we'll just move 3 steps above. 1, and then 2.3 would be, roughly about right there. Something like that. And then 2, 2.1 is roughly about like so. Now, this is all well and good. You hopefully have a good idea as to what your graph looks like, but go ahead and let the calculator graph this. You see a flattening out, not on the x-axis, not right above the x-axis. Remember, let's go back to that +2 that we saw in the original equation. Every bit of the curve was lifted up 2 steps, including what used to be the old horizontal asymptote of the x-axis. What we can say with all assurity is that our horizontal asymptote is y equals 2. I'm going to make a dashed line, a dotted line there, to show that pattern. You can see, yeah, there is flattening out. Our curve gets closer and closer to that line. How about our domain? Well, for all these problems, all reals. There's no x value that you'd get an error with. Everything is fine. Guess what your range would be? Y is greater than 2. The table shows it. You know, you can get close to 2, but you can't equal 2. You can get larger than it. The graph shows it as well. You're leveling off on a flat horizontal line around y equals 2, but your curve is above it. Your y values are greater than the y value of 2. Last one very quickly. Classify as exponential growth or decay. Well, what we've been studying are curves that look like this: y equals a times b to the x. Here's something that you need to know. For our first case, if b was greater than 1, if that base, whatever we're raising to the x power, if that base is greater than 1, then we have what's called growth. Similarly, by way of comparison, if your base is less than 1, then we're going to have decay. Today's graphs, guys, have all been decay graphs. The base was always a value less than 1. So these last 4 problems, we don't even have to graph at all. We just want to know if it is growth or decay. And if I may quickly give you a suggestion, ignore the coefficient. You can even cross it out. Let's go to example 5. Your base is 1/2. 1/2 is less than 1. This will be decay. Take a look at number 6. Your base is 5. 5 is greater than 1. This would be exponential growth. Look at 2/5. 2/5 is 0.4 on a calculator. More importantly, the numerator is smaller than the denominator. Immediately you know that that is less than 1. This must be decay. And finally, look at your base of 4. That's greater than 1. This would have to be growth. So really a lot of problems like what we did earlier, with a few classifications of exponential growth or decay. Hope this is going well for you. Best of luck.